Gauss's law states that electric flux over a closed surface is directly proportional to total charge present in it. If the system is kept in vacuum medium, then phi E is equal to Q by epsilon naught. This can also be represented as integration over a closed surface E dot ds. These are vector quantities which is equal to Q by epsilon naught. What is electric flux? Electric flux is the total normal electric field lines crossing through a surface. Now let us see how it can be proved. Proof of Gauss theorem. Let us consider a charge Q. Let this be plus Q. And this electric charge Q produces radial fields. All these are radial fields emerging out from the charge plus Q. Now at any point P, let E be the electric field. And that point P is at a distance r from the charge plus Q. Similarly, at all distances from this charge, electric field remains the same. Everywhere, electric field is same at the points which are at a distance r from the charge plus Q. Now at P, if the system is placed in vacuum medium, how much is the electric field E? Wherever we calculate the electric field, we need to imagine a unit positive charge is placed. Suppose a unit positive charge is placed at point P. So plus Q charges here, unit positive charges here, and between them there is a distance r apart. And the system is in vacuum. So we know electric field E is equal to 1 by 4 pi epsilon naught Q into 1 divided by r square. And this is directed along r. Now let us imagine a small elementary surface. An elementary surface ds around the charge unity or around the point P. Let us imagine an elementary surface ds. This is the elementary surface ds around the point P. Now through this elementary surface, what may be the electric flux crossing? What may be the electric flux crossing through the elementary surface ds? Already we know that is d phi, or we represent as d phi E, which is equal to E dot ds. Electric field into area vector ds. If it is so, so many ds areas are there on the surface what we considered around the point charge plus Q. So if we calculate all these d phi E over all these ds areas, we get the total flux crossing through the surface. So total flux crossing through the surface, let it be phi E, which is equal to integration of d phi E. We are integrating over the closed surface. So many ds are there on the surface. On integration over the closed surface, what we get is phi E, which is equal to integration over the closed surface E dot ds. And we know we are integrating over the surface. Hence, the total surface area is the surface area of the sphere we considered around the point charge plus q. So, total flux phi E is equal to E into integration over S ds. And how much is this integration over S ds? We know total surface area of the sphere is 4 pi r square. But already we had written E equal to 1 by 4 pi epsilon naught q by r square. E is the vector, so we need to indicate with the vector notation. So if I just write the magnitude of E, I just write as 1 by 4 pi epsilon naught q by r square, that is E. That is E into 4 pi r square. Now you just see this r square is cancelling with this r square. 4 pi get cancelled with this 4 pi. So what we get is equal to q by epsilon naught, which is Gauss's law. That is total flux through a Gaussian surface is equal to q by epsilon naught. Either we can write as phi E or over the S closed surface S, E dot ds equal to q by epsilon naught, which is Gauss's law. Thank you.